I'm recording and I'm going to go ahead and share my screen. All right. Can you guys see my screen okay? Let's see here. Button editor. Oh, good grief. Open up Grasshopper. That's probably a little better. All right, here we go. So a couple of things that I'm going to say maybe while this is loading up. So there's a lot of different analysis tools and stuff here with part of Honeybee and Ladybug. I'm going to show you some files that I'm going to make available to you. So what I'd recommend doing is maybe just watching for the time being. Don't worry about trying to follow along back to your laptop or desktop or whatever your hardware that you're using. Let me go ahead and open the file I was using just the other day with you guys. Yeah, there we are. I just screwed something up. There we are. And I'm going to go ahead and delete that. And yeah, I'll go ahead and, sorry, it's kind of hard to tell because of the wireframe, but we're going to be creating false color maps. We can determine the grid size too to begin to sort of understand how granular the data goes. I believe this was from like January to May or February to May or something like that for Las Vegas, running this thing. And so it's trying to sort of understand where there's actually shadows being cast. But it's not just like a one instance sort of shadow, right? It's sort of understanding how much direct solar gain we're getting on each surface here over, let's say, a specific period of time, okay? So that's why you don't see any crisp shadows, but you start to see sort of ghosts of shadows that sort of build up here. So let me just turn this back on. I think I just hit it, so let me show. There we are. All right. So I'm just going to use the same example that I used the other day. One of them anyway. Here's this massing. I'll go ahead and get rid of this. This is part of the baking process. Save that. Been getting better in getting the habit of sort of compulsively hitting Control S on my keyboard any chance I get. All right. I don't know what that is. A little stray. All right. So there's a couple of things I'm going to try to address here. So yeah, sorry, just sort of zooming out. Okay, I made the make 2D. I sort of hid that. There's my massing. I'm just going to create a new layer. I'll call this draped mass. And I'll call this one color map analysis. I'm just thinking a few steps ahead and giving myself some layers to bake some things into. Okay. A couple of things here. I'm going to open up Grasshopper. There it is. Like I said, once you have Ladybug and Honeybee running correctly, for those that have downloaded it and installed it already, did you have to download and install like Radiance or anything like any other sort of third-party stuff? Where they're pretty seemed like there was a pretty nice like four-step instruction where you download this. So was there like a text file and the zip file that you downloaded or something? Because I have to admit, it was like last spring, the last time I actually downloaded and installed this. Okay, so if not, maybe we can address that at the end of this session and make sure that everybody's on the right track for installing. With Ladybug, we get some ways to bring in some weather files. We might actually use one or two of these tools. I don't know, I guess it'd be over here, visualize the weather data. Yeah, the Cumulative Sky Matrix, we'll use that. So you can see that there's all sorts of things dealing with sun. There's Ladybug, where's Honeybee? Honeybee, right? We can begin to look at other things related to interior spaces. So we can look at daylight factor, glazing parameters. There's daylight factor, radiance. Yep. There's also wind roses and things like that. So there's a raft of tools here related to sun, wind, and light that you probably talked about with Alfredo or Eric or one of whoever was teaching that ECS course when you guys took it. So or maybe you guys are taking it right now. No, I don't know. Anyway. Oh wait, no, I guess it's spring, so never mind. Anyway, what I'm going to do is I'm going to open up a few files here. And again, I'm going to give you these files, so don't worry about it. But I'm going to first go to SunPath. Okay, so I've made a SunPath file, or I guess we say file graph. I guess grasshopper graph. Sorry. Sometimes I could go back and forth between Revit and Grasshopper and what's the other one? Dynamo, and I just get them all mixed up in my head. And I also Control C and Control V in Windows, and then Command C and Command V and Mac. Sorry, my brain is just a complete jumble, and it's all due to like computers. I don't know. So anyway, what you can see is I've already sort of input some things in here, but you can generate that sun path, three-dimensional sun path, and actually trace the sun across the sky. And so let me show you how this works. First of all, this is toggled to true already, but this is where it'll ask me when I first open up the file to give it a specific weather file. So you can give it like the National Meteorological whatever file. I think you can find them. You know, I think there's a pretty good database. If you pick McCarran Airport, McCarran International, I think there's also the Air Force Base up in North Las Vegas that you could choose if you wanted to. But McCarran seems to have a pretty good amount of data in its weather file. Part of that is just sort of, you know, the so there's a mix of information in that, but some of the information in that includes the number of daylight hours in a granular way. So you can also average those out across a month or a year. Also your latitude and you know, information specific to your location, your geographic dot on the map. Okay. We feed that into this big widget right here. Okay. There's a couple of other parameters that we're going to dial in, like where's north. We can also dial in what hour, day, and month we're talking about. We can tell it to do just that one time of the day, or we can tell it to do more. We can actually center up the diagram and have it go like to the centroid of our geometry here. We can change the scale, so we can make it bigger or larger depending on how large our model is or how small it is. Okay. So all of these inputs are connected to slide bars or placeholder widgets like this, right? So for instance, over here, you'll see right click and select multiple geometries. So I can say right click, set one geometry. And what'll happen is it'll center the diagram over the geometry that I pick. So if I right click and clear values, and I right click and say set multiple geometries, I can select my entire model. And it'll find the bounding box for that model, the entire cumulative model, and then give me the centroid, and it'll make the centroid the center of the diagram here. Okay. This can be particularly useful for somebody who's not from Las Vegas and wants to understand where the sun goes through the sky at any given time. So right now, this is set for June 17th at 10 a.m. And of course, let's take it to what's usually the solstice, the 21st. We can, of course, move it across the sky. As June moves into autumn and then into winter, of course, the sun's lower in the sky, right? And of course, if we wanted an equinox, we could say something like March 20th or 21st, depending on the year, right? And then we get a sort of, you know, true east-west sunset, sunrise, sunset, right? Right. So, you know, one thing that I found to be kind of helpful, particularly if you're doing solar analysis for, let's say, summertime, the hot season, versus spring, or the solstice, summer solstice and the winter solstice, is to then begin to give someone a snapshot of where the sun is actually positioned over the course of that day, maybe at like key times, 10 a.m., 12 p.m., 2 p.m., 4 p.m., whatever. So I provided this to you to use. It's fairly straightforward. Over here, I have the sun as a sphere that you can change the scale of, right? So if you wanted to bake that out or bake instances, versions of that out. I also have the ray, the direction of the sun, direct sun rays. Remember, the sun is so large relative to the earth that for all practical purposes, its rays are parallel when it hits our surface of the earth. And so just getting that key direction. And then the actual chart itself, if you wanted to actually, the paths here, if you wanted to bake those in and make those dashed lines or light gray or something for the sake of the diagram. You know, for instance, when I see this and I see the sun way up here, I understand, okay, I'm looking at it in summertime. When I see the sun way down here, I don't even have to look at a legend. I can understand it's at wintertime. Or if I understand it's down here, I understand it's morning or noon, midday, solar noon, or evening time, right? So those, I think, when it comes to just making some really quick and easily to read diagrams, will come in handy, helpful. All right, so there's that one. I'm going to go ahead and upload that after we're done with the demonstration. Okay. Sun path. Go ahead and open up the next one. Downloads. We're going to do direct radiation. Okay, so this is measuring solar radiation. Okay, so let's go through this really quickly, and then I'll do a demonstration where I show you some ins and outs here. You'll notice that there's a couple of toggles here, trues and falses. By default, these should all be set to false. That way it's not going to like pop up a bunch of messages at you as you go, every time you open up the file. And so the first one enables or pulls up a weather file that's stored on your computer. I will upload that for you, one that you can use from McCarran. You plug that in, and then you can see all the different sort of sets of data you can get, right? And like I said, it's pretty nice set of information here. You know, you get dry bulb temperatures, dew point temperatures, you get humidities, you get wind information, you get a lot of sun radiation info. After you plug that in, there's a way to begin to look at the sky matrix here, right? Then later we take the cumulative sky matrix, we can actually break it down and pull out specific times. So for instance, I can look at the amount of solar radiation coming from the sky on average for Las Vegas from, let's say, this month, this day, this hour, to this month, this day, this hour, okay? I can, of course, change those, and I've made those sliders for you guys to define the analysis period. Then it takes that selected sky matrix and plugs it into this, which creates a radiation mesh, and then creates that coloration across the geometry that you're trying to measure, right? Now, there's a couple of other inputs here. Of course, again, a north arrow, that's going to be really important, because if you've turned your model so that true north isn't in the y positive direction, then you'll want to adjust this for true north, okay? And so it'll actually be this way. So that's one thing that we'll need to do. There's also the geometry that you wanted to do the radiation analysis on. You also have to give it any occluding geometry. So any of the context that might cast shadows, you give it that as well. It converts all of these geometries into meshes, and then it basically starts to populate the measured mesh with the rays based off of the solar data, and then it sees what's actually occluded across from different, where shadows and other things are. Now, as you do it over a lot of time, there's a lot of rays for it to sort of average through, right? So sometimes it takes a little while to do this. So what you're going to see is I'm going to go through some of these settings and set them before I start to actually tell it to do its job. These toggles that say false are gates. So for instance, if I just toggle the first one, it's just going to enable this file, or sorry, this module here that asks me to feed in a specific weather file for it to start to analyze. It's not actually going to do the cumulative sky matrix until I toggle this one to true, right? And then it won't actually try to do any of the analysis until I turn this one to true, okay? So there is a fail-safe here in that, you can sort of try to prevent all kinds of like hourglass spinning moments like I had the other day, where I tried to do something computationally intensive and I waited around for it to work and finally worked, and I needed to change one little thing, and then I had to sit there and wait another 5 minutes for it to do it again, right? So a couple of things here. I'm going to go to true, double click that. It's going to ask me for my weather file. Again, I'll give you this weather file. Here it is. All right. Now this widget goes from orange to gray, which means it's actually collecting data. That's always helpful. This one's already set to false, so don't worry about it for right now. The next thing I'm going to do is I'm going to go down here and look at what I want to sample here. So for instance, right now I'm going from May 1st to July 30th for whatever reason. I don't know. I'll adjust these, something like that. So maybe I actually look at, why don't I could just leave it at that. Sure, why not? I mean, whatever. But again, I can get really granular here, right? I can do, if I just wanted for it to be 1 day's worth, I could, set this to be the same month, set this to be the same day, right? Start from 1 to 24. Or if I wanted to, just do a week, I could, of course, change the day, etc. Right? I think you guys get the idea here. How many days are in July? Is it 30 or 31? Yeah, I can never remember these things. I'll just use 30. Why not? Or I can just set it to go to August 1st. How's that sound? Works for me. All right. All right. So now that I have that set, I can go ahead and I'm going to toggle this on. There's going to be a DOS window that pops up. Did you see that? Right. So it's running a freebie copy of Radiant developed by Berkeley Labs, I think. UC Berkeley, and Department of Energy. So it's a free app that you can download, executable on Windows. But it uses the engine from Radiance to generate some of these numbers. All right. So what it's done is it's figured some of this out, but it's not actually producing this stuff yet. I'm going to go ahead and save this. I'm going to go ahead and save this. We need to give it the geometry and the context by which to measure off of, okay? That stuff's over here. Not sure why there's anything in this, so I'll clear it. And we also need to adjust to make sure that north is really north. All right, so right now north is up in the y-axis. I think actually our north is more like, let me turn off ortho, is more like that, right? And so we need to adjust for that, right? So again, just remember that when you're adjusting this, you can adjust the angle, the north angle here, okay? The interesting thing is when you're doing the sun path diagram, the previous file I showed you, right? When you adjust that north angle, you'll actually see the whole diagram rotate. So once you figure out that angle, you just measure it off of Google Maps or look it up by Google, like what's the rotation of the angle from true north of downtown Las Vegas. Then you can input that in here, right? And then to account for the fact that you rotated your model against true north. All right, so we're going to do a couple of things. We're going to give it the context, right, to sort of so it knows exactly what's casting shadows. All right, so I'm going to right click and say set multiple B-reps. And I'm just going to select all the buildings. So I'm just going to right click and say select all objects in the buildings layer and hit enter. So I use layers for that. Just was easier that way for me. Now, here's the funny thing about this tool. It does not like geometry like this. First of all, this is a polysurface. And it's going to have a hard time, and this is the ironic thing about the studio, it's going to have a hard time understanding what's inside and outside. And so what we're going to do is we're going to drape a surface over the main parts of the shell of this thing, along with the ground, any of the ground conditions and the rest of the block. Okay. And then we'll perform the analysis on that new draped surface. Okay, so you can begin to identify the areas that you really have to account for, but you're not going to be actually mapping it directly onto this geometry. Okay, so let me just show you what that means. I'll just do it step by step for you. I'm going to go ahead and minimize this for a moment. Okay, so it's not in the way. And I'm going to go to top view and perspective view at the same time here. So I can see the entire site here. I'm going to go to my surface creation tools. I'm going to find the drape command. I think it's this one, right? No, this one. No, this one. The one that looks like a drape. Okay. All right. Auto spacing, auto detect max depth. I'm going to go ahead and leave this as default. Spacing meaning 5 feet. That's not so bad. So drag a window over the area. I'm going to drag a window over the site and everything on it. All right. And so let's see what it did. It basically gave me a drape over most of the surface here, right? You can see where the drape surface and this surface are sort of coincide together. Let's see if I can turn that off, right? But this is primarily what we're going to be using to actually run the analysis. So you're going to lose the undercuts that you had, right? You start to understand, right, that you know, I have undercuts in here. The drape's not going to account for that. But for the most part, it's going to show us exactly what kind of things that we need on the east, west, south, and the tops, you know, to sort of understand where the most problematic areas are when it comes to direct sunlight, which is super important here in the desert context. I'm going to go ahead and turn the original masking off because I just want to look at this drape surface first. Yeah, there we go. Okay. So now I can feed it this geometry, and it's going to have like literally all the ground conditions, as well as the massing minus undercuts. So let's see, set one B-rep. Go ahead and select that. There we go. I'm going to go ahead and hit save again. I'll go ahead and hit save here. Just give it a second to update. So once we are sure of the sort of time period that we want to analyze, and we have the geometry that we want to analyze, we have north set. I'm going to go ahead and hit true. Give it a minute. A couple of other parameters while this is working. Can you see my blue spinny wheel cursor? There's things like grid size, right? So I can change the grid size. In other words, how often along the surface, if it's putting a grid along the surface, do you want to sample for data, right? And so, you know, the smaller the grid, then the more information you have. You got to be careful with that, especially with these surfaces, right? You increase the amounts in the X direction, also in the Y direction, it starts to like quadruple, right? So you got to sort of like exponentially not, you know, expand how much stuff there's to do. 2 feet by 2 feet is a good module. It's a good architectural module, 24 inches. So I went ahead and just used a grid size of 2. And so it's just thinking about it for a moment. I promise you this really will work here in just a moment. And what we'll see is the radiation result, radiation mesh, legend. That was all part of the stuff that I was deleting when I first opened this file in Rhino for you guys. And I was like, yeah, let's just get rid of this stuff because I'm going to build it from scratch for you. So it's taking 3 months worth of weather data, day in and day out, hourly, and running all of these tests, averaging them, and then taking those averages, red being the extreme and blue being the other extreme, and then mapping color on a grid across the entire surface that we're analyzing, right? So it'll take just a minute, as these tools typically do. In the meantime, I'm going to move this over here. Okay. Now I see there's some chat. Chatter, got to install. Cool, thanks. Mine was a zip file. It had to install Radiance as an optional step. Yeah, so you need to install Radiance. What's 31? Oh, 31 days in July. See, I should know that. It's 30 days in June, I guess, right? All right, I didn't anticipate it taking this long. Yeesh. Didn't take this long yesterday, did it, Gabby? Gabby and I were working on this the other day.
Yeah, it went by a bit quicker.
Yeah. Always, when I'm trying to present this to people, then it makes me look like a jackass. Yeah, anyway, never fails. Thank you, laptop. All right, so we'll just wait for it for a few more minutes. I'll just show you the results. Now remember, this is, what was it, May to the beginning of August. So this is the time of year where the sun's going to be high in the sky. So there won't be nearly as many shadows cast by that neighbor on the north, on the south side. Oh, there we go. Told you. Oh, I accidentally dragged an object, and that's why it's, oh dear. No wonder it's taking so long. Ay, ay, ay. What a mess. All right, so that's what happened. I accidentally dragged with my geometry my cursor. So it's like constantly oh gosh. Oh boy. Oh wow. That's craptastic. All right, so while I wait for my computer to continue to recalculate everything based on this box that I've dragged with my cursor across the screen a number of times while supposedly being patient waiting for it. Yes, I did. I referenced it into Grasshopper. Well, it's actually not too bad. If you think that if you're worried about your computer performance, set that grid size up higher. So for instance, if I set it to 4 instead of 2, I have 1/4 the amount of information it needs to calculate, right? Because if you think about, taking half of the grid away, right? As soon as you add twice as much information in both directions, you get 4 times the amount of information, right? So if you can always step that up and try something simpler, and then try to gradually, incrementally increase it. This was just wow. Well, anyway, you can see here, even in the sort of not responding screen, that it has actually generated the solar analysis, right? So what it's telling me actually during the summertime is that if I am really looking at this carefully, you know, it's not a huge surprise, but the top of my building is gonna need a lot of work, right? Any place that's sort of less than vertical and isn't in shade, right? The shading from the buildings around isn't really doing too much for any of the sort of more horizontally inclined surfaces in my building. Yeah, let's see. So what's interesting, right, is that we get this big solar exposure here along the top. That's not a huge surprise. You know, as this different seasons, as the sun gets lower in the sky, we might have some more issues with particularly that west face. Although we will have more shadows cast to sort of protect east and west faces and south faces. So this will actually give you, I think, more data to sort of understand where the more problematic areas are at any given time of the year. Assuming you don't accidentally drag something across your screen here, which is the most ridiculous mistake to make ever in the entire universe. Bad Josh, bad. It also gives you a graph or a scale here, a sort of legend for the coloration. And so you start to get values. I would show you that if my computer would let me pan, but I'm this close to just throwing my laptop like a frisbee across the room, but I won't. But it really sucks when you're in a hurry, doesn't it? This is where I need like a YouTube video editor. Yeah, no shit, it's not responding. No kidding. Yeah, I don't think I've hung on long enough, dude. All right. So I just went ahead and closed that really quickly. I'll go ahead and open this up and show you what the results look like. Really quickly. A good craftsman never blames his crappy tools, right? I can't remember if there was any other graphs I can just show you at this point. There is that escape. Yeah, I won't go into that. Yeah, so come on. Sorry, now it's having, I probably just need to restart Windows. It's having some memory issues now. It's not a big surprise that memory leaks. So I'm going to go ahead and stop sharing at this point. I will make those available.